Okay, so welcome again to presentation about default entity store. I will share my screen now. Just a second. I hope you see it, right?
Yep.
If you can zoom in a little bit.
Okay, I'm not sure how to do it in Visual Studio. Aha, that's it. Okay, like in the browser. Okay.
Thank you.
Okay. So I will first start from this pull request. This is something what I have made several months ago, and
Miroslav,
yeah.
can you enlarge a bit more the text? Because
Okay, is it good now?
yep. Thank you.
Okay. So in this pull request, you can see changes. You will see why that class is implemented. Several months before, we had for many entities same classes, same actions. For instance, load all force, load success, load fail, load init, and it was repeated on many places for many entities. That was that wasn't so good, so we created the default entity store class. I will go through it a little bit later, but I will show now what are benefits. So this code, we don't need it anymore. All of these actions are created in a default entity store. Other than that, you can see in location reducer, this code is not needed as well. It is placed in the default entity store. We just call that reducer which is defined in default entity store class. So how is it look? What does it look like? You can see this is a trivial example because location is a trivial entity which has just loaded, loading, and error properties, if I'm not mistaken. Yeah. So yeah. Load fail. Yeah. In this case, our location entity store looks like this, and for selectors we have just this line. We are retrieving the selectors from a default entity store class. Okay, this is a trivial example just to show benefits of implementing the default entity store class. How default entity store class works, I will show it here because I have the current implementation here. So, as you can see, here is defined the default entity state, and it can be defined for any entity. T parameter stands for any entity class, so it can be location on master product or something else. And these are properties which are common for all entities. These are some entity options. So as you know, we are using the entity adapter. So we can provide some options to that adapter, like by which field we want to sort, or which field would be unique ID or sort order. And this class uses these entity options. So as you can see is in constructor, we are providing the entity name, that is just a string, and actually that's the name of the entity class, and other arguments as well. This argument is if we have some extra fields beside these ones. If we have, if an entity have some extra field beside those here, we will provide those fields in this object. In this function, we are building the entity adapter options. We don't need to do it in reducer or selectors as we did before. This class will do it for us. We just need to provide proper arguments. And here is the reducer. So you can see these actions are default ones. That's what I mentioned at the beginning of this presentation. Okay, basically that's it. Selectors, entity state selector. Actually, entity adapter has his own selectors, so we are using them. We don't need to create selectors like I will show you now. For instance, for these selectors we get from an entity adapter by default, so we don't need to define them, as you know. Okay, additional selectors for additional properties which are common for all entities. We have these here defined. That's it basically. When we want some of those selectors, we just call this method, which is actually getter. How we use it? Okay. Generally we can see in some component and example. For instance, you can see these store rotations, select select all, or so we defined we defined here rotation selectors. We just import them from this file, and rotation selectors in that file we just have this line. Okay, that's just for the begin. That these are some basics. So it's for very trivial entities. What we can do if we have an extra fields. Okay, for instance, in client entity store we have an extra field which is called update success. We are just providing it to our default entity store class, and that's actually all what we need to do here. In selectors we are retrieving default entity store selectors and adding some new which are not covered in default entity store class. Those new selectors we defined here, as you can see. And in the reducer we just cover, we just add some actions which are not covered in the default entity store reducer. And for all other actions, we use default entity store reducer. So we don't need to cover all actions as we needed before. Okay, that's a little bit harder example, more complex. So we have this is an example for the case when we have extra fields. I I would also show you one more example. When we have some additional code in the reducer, this is for contract reducer. Contract entity store also has just one extra field, and it is the same field as we had in the client's entity store, and so that's nothing new. But in contract reducer, we have some transformations of data. This is you see we have a load success actions here. We already have that processed in default entity store reducer, but since it is not enough just to call that reducer, we need to do something additional with this data. Then we can resolve that case in this way. So first we call default entity store reducer, and after that we can do what is needed with data which are returned by that reducer. So if I go to this function, you see this is that logic. Also, since Marco was working on this contract entity store, and I was just together with him on some issues he had, and one of the issues was this object couldn't be cloned properly because we had date object and something like that. So that's why we introduced clone deep method from Lodash.js. And yesterday I have replaced all JSON parse and JSON stringify methods with the clone deep method. And I will just say that clone deep is not the only useful method from Lodash.js. We can use many methods from that library. It is very useful generally, and I would just recommend when you need to write some new functionality, for instance, new utility function or something like that. Maybe it would be good to check if it is already defined in Lodash.js library, because you will save your time. You will not need to implement that utility. Okay, so that's basically it, what I have planned to explain in this presentation. I know that you had some issues during your implementation of default entity store, so I'm not sure if I covered all of your issues. So if you have any questions or concerns, feel free to ask.
Miroslav, it's more of a general question rather than an issue. In the client reducer, you had a client actions factory.
Client actions, sorry.
Factory. Client actions reducer.
Yeah.
You had the client actions factory. That one, the
this.
Client actions
okay.
Factory.
Mm-hmm.
Isn't that just an enum? Why do we need a factory for it?
Yeah, generally, you know, that is something what Christian Dalea has implemented, and actually how it works is it takes name of entity class and you see, it generates all default actions for that entity. There are places in code which where we don't use this action types factory. I noticed it, for instance, in I think in product display page we don't use it. But why is good to use it? Because what if entity name actually what if entity class changes? What if the name of entity class changes? Generally, we have a convention to name action types in this way, like build tag works. So in these brackets is the name of entity class, and after that we specify action name. So we use action types factory in effects as well. So if I go here, you see we are using here as well. So if we one day change the name of entity class, we will just do it on one place. Because you see contract name, we will just change this name, and everything will work as before. If we wouldn't use action types factory, then we will need to change that name on all places where needed. So that is why I would recommend to use action types factory.
Makes sense. I wasn't aware of the build tag method for the action naming.
It was originally built when we had first introduced default stores. We had introduced as a way of standardizing the way that you build the name. So when multiple stores try to build their own set of actions and things like that, even when tracking and even when debugging the code and things like that, we would always look at the same structure. So we would always see as a square bracket the name of the entity space, one single space, followed by in all caps the name of the action being performed. Whether you introduce your own action, whether you introduce anything, the build tag is agnostic to it and will be able to build whatever you need.
Yeah.
It's just a string builder, to be fair. It's nothing special, but it's just as a kind of uniform builder.
Makes sense that auto-generated.
Yes, well, for them to have auto-generated and to be one for each store is quite good as well.
So yeah, so thanks to Tristan Relais, we have now we don't need any more some effects defined, like these load locations, init locations. It is all defined in default load effect. So I can see that I can say that we have a good mechanism for implementing new stores. So are there any other questions about this?
Not from the Malta side.
Okay, Serbia.
There's one.
Would be helpful to have a Yeoman script to generate the photo.
Do you get that for us now?
Sorry, no, I didn't hear well. What is the question?
Francesco suggested having a Yeoman to
Create command to generate.
a Yeoman script to generate the default stores.
To generate what? Sorry.
The default stores.
even a normal store.
Or normal.
It's something that is standard.
Implementation already.
Like generate a new store using the default.
Basically, they generate a new store and new store.
Okay, sorry, I cannot say that I understood it well, but maybe that's a question for Arthur.
Maybe.
So when it comes to auto-generating stuff, Yeoman is more meant to work at the project level. So you would generate a setup for a module or for a project, and to generate a piece of Angular application, you would normally use Angular client, right? Like some of you guys might do when you need to add a new component and so on. You just do, ng add component and so on. And for that, schematics are used. And there is actually something that it's not related in any way to to the facade that we built internally, but there are schematics ready to automate how the Redux code is added to the project. I think I shared the link some time ago. It's from the NGRX. They provide schematics for that as well, so that you can do ng-add and then a store, and it will wire up everything for you. But if you would like to have something like that for the default stores implementation, then you would probably need to use schematics as well, and have that ported into the Angular client. So that's how I would see it. I don't know if that answers the question.
Arthur?
Sorry?
Clayton mentioned, would you see value in it, or?
I wouldn't really bother because for the default store, we already have the facade to limit the amount of code we write, and that's exactly what schematics are for. If you have something like that you consider a repetitive code, you can automate that with schematics. And we took a slightly different approach here. So I wouldn't really bother, to be honest. But that's from my point of view, right? You might have different opinion. If you find value in it, feel free, to add something like that to your tool chain. I don't see any problem with that.
Do you remember the original motivation for the double cache error handling? Could you reiterate a little bit about it, please? Can't hear you, Miroslav.
Sorry, I was muted. Sorry. I'm not sure if I understood well the question. Do you mention something related to this?
Yes. Could you reiterate a bit about the reason why we have the double cache error? So we have the cache error within the switch map and on the outside, and what its original effect was, and what motivated this approach.
Yeah, generally that's something what you guys found. It was maybe not. It was a long ago, but actually, what we are doing here, we are catching error. Actually, at this moment, I am not sure for which exact observable we are doing it. So I guess, yeah, we have two pipes. For one pipe, this is catch error, and for this pipe, it is this one. So as I can remember, that's the reason why we have two catch errors. Please correct me if I am wrong.
I think originally there was an issue where one of them throwing an exception would stop the effect from working in total. And we had originally moved the catch error to the outside, and then we realized that we needed it in both places.
The issue before was that when the catch error was being triggered, then any subsequent effect did not take place.
And which one was it, the external? Because I'm wondering whether both of them are necessary, or whether one of them is actually going to break the implementation anyway.
I think, I don't know if I'm understanding it correctly, the bottom catch error might be there if we get a mistake in there's a problem in the get by ID. It's not in the outer pipe. And the inner catch error is there if we find a problem with the map. That is how I understand it. I think the outside, the one line 25 is there for the code in the outer pipe, and the catch error inside. Now, I don't know what happens if you get an exception in the inside map, whether if there isn't the catch error, if it will keep bubbling up or what happens. That might be the problem where you have one and not the other. Is that if you have, for example, an error inside the second pipe, it might end up bubbling up and the effects are like broken. From how I understand it.
Yeah.
But without catching it, what you're saying is that it would break the entire expression.
This is how I'm understanding the code. It's not. I didn't try it out or anything.
Sorry, it's worth mentioning that switch map operator, it creates a new observable. So this we have one observable here, and this switch map operator creates from this action a new observable. For every time when this action occurs, we will get a new observable here. So that's why actually we have this catch error is for this inner observable, and this catch error for outer observable.
Okay, thank you.
Okay. Any other questions?
We're fine on the motor side.
Okay, thanks. Serbia or Poland.
That should be it then.
Thank you very much.
Thanks a lot.
Okay, thank you very much. Have a nice day.
Thanks.
Bye bye.